Hello kids. So in our earlier video we have already seen the derivation for resistances connected in series. Okay, so what was series? Series was that the resistances are connected or the resistors are connected one after the other, right? End to end, one after the other. Now in this video we are going to see the derivation for resistors or resistances connected in parallel. What do you mean by parallel? Here you can see that these three resistors R1, R2 and R3 are not connected end to end. They are not connected one after other. Okay, so what is going to happen is, if there is current I which is being flown in this particular arrangement, so it will split into these three paths, right? Okay, so they are going to, that current is going to split in these three parts. Okay, and always remember that the current flowing through any path is inversely proportional to the resistance. So if resistance is greater, the current flowing through that path will be less, and if the resistance is smaller, the current flowing through that path will be more. That's common sense, right? Okay, so let I1 be the current flowing through resistance R1, I2 be the current flowing through resistance R2, and I3 be the current flowing through resistance R3. Okay, and I is the total current. If I is the total current, it means that the total current is the sum of individual currents flowing through each resistor, right? Okay, so I is equal to I1 plus I2 plus I3. So what is going to happen in this particular arrangement is, as the three resistors are connected in parallel between 2 points A and B, the potential difference between the 2 points A and B is going to be same for all the three resistors. So potential difference is not going to drop. Okay, in series the potential difference dropped, right? Okay, so in this case potential difference will remain same for all the three resistors. Remember that potential difference is same throughout, okay, for all the three resistors. Now according to Ohm's law, V equals to IR. If V equals to IR, then I will be V upon R, right? Okay, and this is what we are going to substitute for I in the above equation. Okay, so what will happen is, this I can be substituted for V upon R, right? Here we are going to denote this with Rp. So what is Rp? The effective resistance of the arrangement where the resistors are connected in parallel. So V upon Rp. What will happen to I1? It can be substituted as V upon R1. What about this? V upon R2 and V upon R3. Why we haven't written V1, V2, V3 here? Okay, as we know that potential difference is same throughout, there's no need to write V1, V2, V3. Okay, so let's do some math. V be common, 1 upon R1 plus 1 upon R2, 1 upon R3. So this con, and what we get is 1 upon Rp equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Here we have connected only 3 resistors, so that's why it's up to R3. What if we have connected n number of resistance? if we have connected n number of resistors, then this equation will be 1 upon Rp equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3 goes on till 1 upon Rn. So this is the derivation or the equation for the resistors connected in parallel. Let's see the characteristics of this type of arrangement. So we are going to see the characteristics of this arrangement. Number 1 is the reciprocal of effective resistance, that is 1 upon Rp is equal to sum of the reciprocals of individual resistance, right? The reciprocals of effective resistance is equal to sum of reciprocals of individual resistance. Second, that the value of Rp which we are going to get is always smaller than the individual resistance. Okay, the value of Rp will be always smaller than the individual resistance. Third, that the potential difference will be same for individual resistance, for R1, for R2, for R3. Okay, and fourth, that different current will flow through each the current flowing through the individual resistance will be inversely proportional to the resistance. Okay, this we have already seen earlier. Okay, if the resistance is greater, the current flowing through it is smaller, and if the resistance is smaller, the current flowing through it will be greater. Okay, and this type of arrangement we use to decrease the effective resistance in the entire circuit. Okay, so do your best. Meet you in next video.